is the working with repetitive data tasks in R workshop or data club session. My name is Wei Ying. I'm the Research Support and Data Services Librarian. My team is called Research Data Services. If you have the link on the slides, you can go to my team's website. And if you have any data questions is related to how to find data, use any data analysis tools, you can use the data@library.columbia.edu email address. Here are all my colleagues, Mosir, Jeremiah, and Eric. So if you want to know them more, we are all here under Meet with Us or Research Data Services Librarians. So you will see our different specialties. And we do have research guides over here to the lower right corner. So you will see many different topics related to different types of data. And that will cover a lot of our services just for your information. And if you want to ask us more related to our services, we can come back later after the session. We are all here for your questions. And the reason I want to teach today's session is based on my daily communication with different users, like our users on campus. It doesn't matter, they're students or they are more sophisticated researcher. And sometimes people think about repetitive data tasks only about iteration or only about how to write for loop or while loop, those very advanced things. But for many people, I believe among all of you, you have different levels. Some of you maybe use R a lot and you use very little. You probably only know how to open the RStudio interface. And actually, this topic can be from the easiest to very hard. And the purpose today is not to teach you how to code, because now we have AI. So you can easily just ask AI something like, oh, I want to code in this kind of thing. Could you give me a chunk of code? But the problem is when some people bring those AI codes to me, I realize one problem is for this type of question, like how to deal with repetitive data tasks, AI give them very, very hard code, which will drive them crazy. And that is because if you tell AI you are a researcher, you are doing serious research, AI will give you textbook level quality code, and they will drive you crazy because they don't want to think they are a very easy guy, give you very easy code. So in that case, a lot of people will feel like they still cannot use AI for their coding. And to be honest, what I'm going to start with is I will tell you the reason we are not doing live coding today is because the first thing you need to remember is R is a functional language rather than a general programming language. So what does that mean? If this is your first time to learn functional language, that means there are so many functions you can use directly. That is why people choose R for data analysis, or more specifically for statistic analysis. And if you want to use Python for this thing, that's fine, because Python is general purpose, including do data analysis. But because you have so many existing functions and packages, you should consider about those existing ones firstly, then consider about define a function, like a lot of AI will tell you, because they think this from an engineering background. And from CS people, engineering people, coding from the scratch is the basic thing you should do. That is your fundamental skill. But for many researchers who want to use R for data analysis, coding is just one tiny part of your research work. So your purpose is how to make the coding process more efficiently and simplify your workflow, rather than think about in a very thorough way to make you think this research is too hard and you don't want to move forward. So that is the first thing I want to make sure everyone understands is, for some of you here, you are probably, let's say, in primary school, you are learning math. And if people show you Columbia Math Department's graduate school syllabus saying you should learn this and this, that doesn't mean that syllabus is not good, but you're not there yet. And sometimes maybe the math professor at Columbia cannot solve that problem the same easy way as your teacher in that primary school, but you should do step by step until one day you get into college, you get enrolled in graduate school, then follow those very sophisticated syllabus. So I'm not like saying you should not write your function or create your own packages, but you need to have a self-evaluation if this is the right timing for you to do. And also, writing function, even writing a package means you are going to have a child. That means it's a sustainable thing. You need to keep it, right? Once you release it in our user community, many people will use it. Then you need to really maintain it, keep updating, do version control, and do debug, etc. So you need to think about you are capable enough to do this thing, but also can you keep a long run? So that's why I think a lot of people underestimate Tidyverse, even they use Tidyverse a lot. And if you don't know what is Tidyverse, that is the core package everybody should know if you begin to use R. So there is no exception. If you don't know Tidyverse yet, there is an online book called R for Data Science. So the whole book is to, yeah.
Move the mic up to your collar.
Like this way?
Yeah,
Okay, sorry. Yeah, so Tidyverse is a must to learn. And I will start with how to use Tidyverse to solve your repetitive data tasks. So that is why on this slide, I only highlight 3 different functions because I think some of those functions are very difficult for beginner to digest. For example, nest. A lot of people, if you are the first time to know what is list, what is vector, you will feel very frustrated. I listed here, I'm not going to explain those words because I want later do the demo. You will see by your eyes. In a visible way, you are going to see how tidyr package want to nest the table and how to solve some repetitive data tasks. And to the left side, dplyr is a very basic package from Tidyverse to solve across column and across row operations. So if it's a cross row operation, it's row-wise, right? If anyone knows this word, that means this is cross rows. I want to do something repetitively. And the reason I put across here is because if you see my slide, under row-wise, there is another thing called C_across. So when you solve row-wise operation, you are going to use maybe C across. And if you only want to do a column-wise study, you use across. So sometimes people feel very confused about those things. I want to put them there just for your information. Later, when you ask AI, maybe you can think about through those angles. It's not like we are going to cover everything. And I do give you the Tidyverse page for both functions. So if you want to know more about row-wise operation and column-wise operations, you need to know before jumping to for loop. Think about dplyr, those column-wise operation, row-wise operation firstly, because they are very, very powerful. You don't really need to write if-else condition because many of those functions can help you to do that. For example, they can do many, many things like summarize across all the character columns. And the same thing, do aggregation across all the rows, like row by row, do many, many columns together. We're going to use the first scenario to do that. And a little bit advanced is a lot of people feel so scared about this one. I don't know how to pronounce that, call it purrr. And so this is definitely the iteration package in R. And many people don't know how to use it is because, again, we come back to the last slide. You need to have basic R structure, data structure understanding. What is vector? What is list? If you can understand vector and list very well, you won't have many problems in using map and work. But we are not going to talk about data structure. It is dry and it takes maybe 1 to 2 hours for me. I used to teach R in data structures. If you need, contact me. we can talk about them more. But today, I will, again, use two functions to show you the similarities and differences using like a visibility thing. So for map, I listed here, we want to apply the same function to many, many different files. And also, map can do the same thing, like across the row, across to the column. But also, map is something will happen in your R environment. So that is different from work. So work is the same thing. You apply the function to many, many files, but you only see the change on your local computer. So you only need to remember these two differences. Map is for any data change in the R environment, and work is the change you make on your computer. For example, you want to save files on your computer, you use work. If you want to change your data structure, your data shape, you use map for repetitive data tasks. And if we still have time today, this is a little bit like a further one. So we are going to use the Columbia Academic Commons API to download a lot of data. So if any of you know API data, so there are tons of data, you probably need tedious work to download those records. And very, very basic thing for engineering school, people will say, let's write a either for loop or while loop. For example, you know I have 100 web pages I want to download or scrape all the information. We definitely will do for loop from 1:100. Then I write a function. Then let's iterate the same function for page 1 until 100. So this is for loop. The difference between these two will be the while loop is you need to set up a certain condition. So for example, you don't know if it is 100 pages, but you know I want to download until the last try is empty. And when you find it's 0 or empty or none, then let's stop. So this is the difference between for and while. And I give you a script using while loop to download API, but also I give you a similar script, download the same API data using an R package. So I'm not trying to tell you you really need to rely on package, and if there is no package, you should not write your function. But again, I want to emphasize there are really many, many R packages because this is a very matured user community. And maybe if it was in 2010, I would not say like this, but this is 2026. There are so many R packages for different disciplines. What I mentioned to you is very general for all disciplines thing. If you are from medical campus, there are so many biomedical related R packages. So you know, like for specific thing, even you think the algorithm is so difficult, maybe econ, business have their own R packages, climate change, or any science like environment studies, they create their own things to deal with those work. And so that's why I asked AI to develop some code example for me to deal with those, you know, look back, look ahead, those time series studies thing. And of course, automatically they give me this for loop to say, okay, if you want to do the detect the anomalies, you should do this for loop because you have variations by days. If you look back to the 7 days, look further 7 days, you should do da 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 da. And actually, this type of thing have many different packages. I only listed 2 different packages, like slide R or anomalize. Those kind of packages can definitely help you write one function to avoid the for loop or while loop thing. But again, now, because everyone has AI to help with coding, I want to suggest you until today, like it's February 2026, AI can always give you different answers by time because they are still keep updating their like answer pools or they are still learning things. So the first thing, if you want AI to help with your coding, is you need to know exactly what you want. You ask them very clear thing rather than just say, I feel like I need to have a loop, write me a loop. If you say like that, they won't tell you any package thing, right? Because you don't know there are some functions or packages are there. And sometimes you will receive very, very good code, but you cannot digest. Then keep asking until you can understand each line and also validate. I met several cases when I run those code chunk, I get error, I get bugs, and I need to re-ask AI how did that happen. And so that is a kind of self-iteration part. You need to ask AI, then ask it again. And you need to have some basic sense of feeling if this is the correct way. And in order to prepare today's session, because I know like attendees levels could be from beginner to sophisticated, I keep telling AI, I say, can you give me a little bit simpler code so everybody can read? Don't just pretend I'm an engineer, right? And maybe I'm a researcher. I have a lot of knowledge in my discipline, but coding is just some side work for me. I have other concentrations. So you don't really need to teach me a lot of terminologies I don't know. So that is all my slides, and we are going to jump into each scenarios. And again, if you have any data questions, this is my team's email alias. And we do have other data club sessions in next week for geospatial data. We're taught by Eric sitting over there. And the last session on Thursday, next Thursday, will be taught by Mosier related to Python, right? And you can use that link to go to the full schedule. And now let me go to my folder. And I hope everyone has downloaded this folder and unzipped. If you have the same scenario 1, 2, 3 R script and a folder called basic company data, I think you are good to go. And I always teach people at the same, last time I say, please open your R script in this folder so you don't need to worry about working paths. So I will start with scenario 1. And if I open from this folder, you are going to see in the console over here, it's exactly the current folder working path. So what I'm going to do, I type get WD, and I will make sure, so every work I'm going to do today will be within this folder. Then you don't need to worry about you cannot find the data folder or something else. So life would be much easier. So here are several packages I listed here. I want to highlight, doesn't matter tidyr, purrr, dplyr, they are a part of Tidyverse family. So you have different options. I told you different functions are from different packages. But if you load Tidyverse, you basically have all the functions ready in your environment. But you need to pick either load 3 packages, like line by line from line 2 to 4, or just like what I did. I just load the whole Tidyverse, so I don't need to worry about I missed any function from a specific package. And I'm going to use the built-in, the Tidyverse built-in data set called Star Wars. I think some of you probably know this better than me. I just watched probably 3 movies, and based on the column information here, definitely they have more films than 3. And different character like Luke or R2-D2 or Leia or someone else, I don't know, they appeared in different films. So the first question probably I want to ask is, yes, I know many different people here on the first column. I know they have kind of like democratic information, but I don't read very clearly what kind of films they are in. I kind of know many of them played more than 2 or 3 or 4, but if you want to know what is this film's type, if I use type of Star Wars, dollar film. You're going to see this is the list. So again, it's come back to the basic understanding I mentioned. If this is the first time, you just need to remember, if this column is a list, R cannot use it for data analysis. R can only do data analysis based on character, numeric thing, integer, or logic, that means yes or no, 1 or 0, those type of data type. And for list, this is a more complicated data structure, a little bit higher than those vector I mentioned. And if you look at each row, so they use the C and the parentheses to put all those film names together. So that means for each row, that's a vector. But the whole column is not a vector. So what we are going to do is, if we really want to do some data analysis in R, the first thing is we need to change the whole films as the whole column type will change from list to a vector. And in this case, it must be a character vector. So that is exactly what I'm going to do for the Star Wars clean data set. So what I want to do is, I say Star Wars, I want to only select the name and the films, so that because I only want to do operations based on the name and the films column. And you see row-wise is here, because every different row has different variations. So we are going to do row-by-row operation. This is very tedious, repetitive data task. And remember, you need to enter into this row-by-row mode, call it row-wise. Then you create 2 new columns. The first new columns is we count the length of each vector in each row. So that is the length parentheses films. And the second will be what they are. So that is the paste. Then we will paste everything together for the film list column. So in that way, if we run the whole chunk, of course you need to exit this mode using onGroup. After that, you are going to see immediately, first thing is you count. Okay, Luke appeared in 5 movies, R2-D2 7, and Leia 5, and Owen Lars 3, something like that. And if I recall based on type of, then say Star Wars clean, dollar film list. So this becomes a character vector. So you are going to see they don't have this combine C and the parentheses and those quotes. So they only put all those information into each line or each row. So that from then on, probably you want to do some text analysis, I don't know, based on this list. That is fine. So this is one way to help you understand. You don't really need to use a for loop to write such kind of thing for row-by-row operation. And we don't have a very good numeric example for you to understand how to use it for that thing, but I can show you a wrong thing if you forget row-wise. So for example, I know like height, mass, or birth year, they cannot be combined together, right? But for example, you have 3 random columns. You want to create an average value based on the 3 number. So very basically, you want to do height plus mass plus birth year divided by 3, right? So this is a very easy thing to do. And if you just do Star Wars, let me create a name for this type of thing. It's like HMB. So we still use the same Star Wars. And the most easy way is you say we mutate, we create a new column called average, AVG, HMB. And you say mean value equal, then we put all the height, mass, and the birth year there, and see if it works. What is the arrow? So trim, but I don't have trim. Let me double check. Say it again.
I think mean expects only a single data argument.
Oh, okay. So maybe that's correct. So we put the vector C there. Okay, great. You catch that. And let's see what is the result for the HMB's last column. They give you an A. So that is because you forget the row wise. However, you should also be careful. Even we do row wise, right? So before we do mutate, we say row wise. Oops. Then we do a pipe. Then, of course, we do on group. You also need to double check what's going on there. You still see some NA. And this time, this is because you didn't forget row wise, but you need to double check for birth year or some other entries, even for, I don't know, maybe math and high, they do have, yeah, for math, they do have some entries, they have NA. So you need to remember NA.rm equal to true, like remove NA or do other data strategy. But this is just something to give you a memory. Row-wise is important if you want to do row-by-row operation. Okay, so the next thing, we do the opposite, right? We come back to the Star Wars, and we do some column-wise operation. So the column-wise operation is, I want to know the distinct number of hair colors. I want to know the distinct number of skin colors, eye colors, and the other like character categories in one shot. Because you probably can do something like you type unique, then you can do Star Wars dollar hair color. Then you can print out all different types of hair colors they have. But in that case, if there are many, many columns, you do it like copy, paste, and change that column name. And for this time, if I just want to say how many, I just need the number. I just say across where is character for the whole data set. Then do n underscore distinct. Okay, I forget the parentheses. So let me just run this chunk. So immediately you are going to get, there are 38 species and different types like 12 hair colors, 15 eye colors, which is beyond my imagination. And if you really, really want to know like what I did, the unique values for each column, the map function can help you. So that is the next chunk. You select where is character, then you use the unique function like what I write in my console, apply to all the character columns. So that is map unique. If we do that, you are going to see in one shot what the unique hair colors, what is the unique skin color, eye color, etc., homework. So you don't really need to do everything manually. So this is something people easy to miss in the basic tidyverse. This is nothing fancy. This is your entry-level function you should remember. So don't need to even worry about those loop things. So that's a good thing for tidyverse. And in the case 2, for scenario 1, we're going to use a different data set called Gapminder. So you need to load the Gapminder library. If you don't have it, every package, if you fail to load, you can install under the package tab. There is an install box you can click instead of coding. Because I know for some people, even install the packages, sometimes you might have problem in typing. But so if you want to install any packages in class, feel free to use the install button under the package tab. And after you load the Gapminder package, you can easily load the built-in data set called Gapminder. And this is a very useful data set we use for many, many different types of demo. And if you look at the whole data set, they have 142 different countries from 5 different continents from 1952 to 2007 in a 5-year interval. They show you life expectancy, population, GDP, those basic information for the whole world. So now, my question is, the first thing is look at the basic the Gapminder data. This is a very normal data with 1,700 rows, 6 columns. But now, I want to nest it. So I told you nest is very hard to understand by words. But if I do the nest by country, just use this code and I name it as data by country, create a new object, you're going to see what nest will do. So it's different. So once I do nest by country, I get a new data frame. The first column is that country. The second column is that data frame for that specific country, like Afghanistan has its own data frame already. So you are going to say they can still give you this table icon. You can click on, and you will say data by country. The double square 2 means this is the second column, data column. And the double square 1 means this is the second column's first item. So this is go back to the basic data structures in R. And if you cannot digest, no worries, because we are not going to use that. But just in case you want to know what they are, I'm telling you. The double square means the dollar. So the dollar is mostly like commonly used by most of the R users. But the basic R use double square to indicate the second column, like data in data frame scenario. So now, I want to run regressions for every country. So if we go back to here, right, we have life expectancy, population, GDP, and we have 142 countries. If I want to run any regressions based on this database, that's impossible. I need to split them into 142 maybe subsets, then run the regression. Or something is you say, oh, we can take advantage of the data underscore by country. That's true. So for example, if we want to run a Afghanistan underscore model, right? The function is LM, and I say maybe life expectancy is the outcome, and the GDP per cap is the independent, the X variable, and I could just say data equal to, from this data by country, then I do the same thing. I say data, let me try the first one, because I know this is Afghanistan. And successfully, I get it. So this is the coefficient for GDP per cap in the console. However, if I want to run all the similar models, I probably need to do 141 times again, copy, paste, copy, paste. So this doesn't make any sense. So that is the next chunk. For the reg models, based on data by country we have nested well, we can do, okay, mutate. Yes, we create a new column. We use exactly what I put this function into the map function. So data will be this data column we have created. And the tilde is just, I begin to write my function. So this is just the grammar. And the data equal to period X means every single item under this data column. And if I run this reg models, and let me open it, you are going to see this new outcome is a data frame. I have country, I have this data column, plus the model column with all the coefficients, all the regression model outcome. And if you are familiar with regression, you probably would ask me, this is not good enough because I need to manually extract this useful coefficient for GDP and put them into a certain places. We need to knit it up so that its publication quality, journal accepted table look like same. And how to do it? This is still very tedious. I cannot extract the coefficient manually from this long column, right? So that is exactly what we are going to do, use the library called Broom. So Broom is Broom to clean up this very messy outcome. So we load this part of Tidyverse package. And what we are going to do is, so if you know a little bit about regression, you need to know when journal asks you to report, at least you need to have p-value. And p-value less than 0.05 means it's significant. And you need R-square to see how well fitted your model is. And you probably need a few other things. And if you look at my current console, this model output don't give me any of those type of useful information yet. That's because you need to use one function called tidy. If I put this Afghanistan model here, you're going to see if I use tidy function, I will immediately get p-value, standard error. I still keep this coefficient here called estimate, right? But I still don't have R-square. But there is another one called glance based on the same Afghanistan model. You are going to see R-square, adjusted R-square, and AIC, BIC, degree of freedom, which is DF. Those useful coefficients or parameters I want to report to the journal. So you say, okay, great, I know these two functions. Then how to extract those informations together? So that's a line 44 and 45. We use map. And this MOU is, come back here. This is the MOU. We are going to do some change. So I say I want to map the tidy function to MOU and save all the things called tidy stats. So pretty much like here, I have estimate, standard error, statistics, and p-value. I will use tidy stats to wrap up them. And for glance stats, I put the glance function to the same column. And then I do unnest. So the unnest will help me to rename them in a nice way. So later you are going to see all the results from the tidy function. They will have a prefix called tidy stats. And all the results I get from the glance function, they will have a prefix called glance stats. If we run the whole chunk again, the results look like this. So we have more columns. But definitely from here, you can pick and choose which one you like. So this is the p-value, this is the R-square, this is the sigma, or other thing. So you don't really need to do it by any manual work. So here is the final table, right? Because this is a really wide table, and we don't really need every single column to report. So I will just pick something I think my journal needs. Then we just come back to the basic dplyr. We filter out, we only need GDP per capita's coefficient. And we only select 4 columns. They are country name, the slope equal to the estimate, p-value from the tidy function, R-square from the glance function. Then we get a final table. And the final table looks like this. So it is very, very close to the journal style. However, you're going to say it's still a tabulation, right? And for the real table, you probably say, oh, we still need to add title and do some font size and do some formats. I give you this chunk. I'm not going to talk detail because this is not repetitive data tasks. I used to have a workshop about how to do tables. If you are interested in it, I can share my slides or my R script with you. But there are so many different packages. I use the, the GT package as an example, and I show you something look like this in the viewer window. So this is just one way to wrap up that simplified table into a publication quality table. And for different journals, they may or may not like this type of table, but I would say there are many variations. This is scenario 1. I want to go to scenario 2, so if you have more questions related to table formats, we can discuss later. Any questions so far? Okay, then let's open scenario 2. And open file, sorry, not open. Open. So for scenario 2, because we didn't close the current R environment, right? So I don't think we need to load Tidyverse and Gapminder because we still have Gapminder in the current R environment. So if you don't see Gapminder in your R environment, you might have some problem. You need to make sure Gapminder is loaded, and both the library and the data line. And the first thing, as I mentioned, is just now we do some regression by nest. But some people might think, I still want to have different country data set in CSV, how to do that. So I'm not going to show you 142 times thing, so I use continent instead. So I will show you, you can use the split function to do by continent Gapminder subset. So if I only do split on line 10, and let me print out a continent list. So if I do continent list by the split function, you are going to see they are still come together in the output. And if you read the global environment, for the continent underscore list, it's still a list. It's not a data frame, right? If you look at the final table or Gapminder, they are a table or they are a table. Because if they are not a table, you cannot use it for data analysis. So again, we need to change the format, split it really into individual items in the environment. So that is our goal. And how to do that? Before we do that, if you look at the console I print out here, we still see the Africa table, Americas table, but they just name as Africa, America. In order to name them in a very consistent way, that's what I do for the line 12. I just paste the gap underscore to every continent list name so that once I re-type names, continent list, all the 5 tables, they are going to be Gap Africa, Gap Americas, Gap Asia, etc. Then you do list to environment, and immediately you are going to see the 5 tables in your environment. So this is something you can see in a visual way. You split them, and the list to environment will help you to create individual objects in the list. So you don't really need to do filter or select those things, manually create them. If you know there is one indicator you can split them, this is a very efficient way. And now you probably want to say, okay, I have 5 subsets for the different continents. I want to save them on my computer in CSV files. How to do that? And again, we can do by nest. Then, so firstly, we do the nest function again. So this is the step 2. We're still based on the original Gapminder. And you probably know if I only run gapminder nest, so for example, I run from nest until by continent, it looks like this, right? So currently it looks like this. You have a data column wrap up for each continent. But what I want to do is I want to create a name for my local computer. So I will mutate a file name column for this nested gap. And after I create the name, you are going to see there are 3 columns. The last column is file name for different continents. So those are the names I want to save locally. And if we prepared well, so here is the work coming, because you want to save those files in the local drive. So you would say, I have 2 parameters, x and y. So that means I have 2 columns, data column and file name column. I want to do some operation. So the period x would be every single data frame under the data column. And the period y will be every single item in the file name. What I want to do is a function called write.csv. This is the basic function. And the x is the data file I want to save every single data frame. And the file is equal to this name. I call it y, right? Any file name. And the row name is 1, 2, 3, 4, so they automatically give you the row name. We don't need that. So if I do work 2, again, you won't see anything happen in our environment. That's work. Go back to your local computer. In your local folder, you are going to see gap, the 5 CSV saved in the current folder. So this is a way to create your subset automatically. Does that make sense to everyone? Okay. So now let's do a little bit further, because we can save files to local. Then how about we import something from local to the R environment? So in this part, you need to use a file system, so FS package, also a part of Tidyverse. And so you don't need to set up your working directory. I think everyone currently are still in this working folder, right? And what we are going to do is you are going to find that working folder has a folder called basic company data. And I will name it as local folder, so we don't need to write this name again and again. And if you click into that local folder called basic company data, you are going to find 7 zip files. And you don't need to unzip them, because that's how I want to show you. Because I know, so this is an open government data. I randomly downloaded from, I think, UK government. I give you a doc file. There's a URL link. You can come back to the original website. So they just show maybe by 2026, January the 1st, how many companies registered in UK or how many British companies registered worldwide. So there are many those basic information. So we're not going to talk about anything inside. But I know the reason they zip them into different files is because they think it's a little bit big, maybe over 1 gigabyte. So they want to zip it. But if you unzip everything, that will be a CSV. And in order to save your space in your local, they want you to download in zip. And we are going to read those zip files, then unzip them in CSV. So how to do that? That is from line 3. So line 3 and 4 is basically if we don't want to go back to the local folder, you can write a simple directory list function to print out what you can find in that local folder, And they will tell you, oh, we find 7 zips, right? And for unzip them, again, because if you want to unzip, that is something on your local computer. It's work. It's not map. So to still you want to do something for your local computer, we can use the unzip function for every single item, the .period, in that external directory we defined our local folder. So if I run the work function, immediately you are going to see a red button on the upper right side. They are saying I'm processing. And if the red button is gone, that means you have successfully unzipped everything. So let's come back to the local folder and see you automatically unzipped everything. So maybe 7-zip file manually unzipping is still fine, but if you have 15 or 30, right? So this can be easy for you to do everything in a shot. You can also do in terminal or other more CS-based tool, but if you are just a R user, then this is a good way for you to know. Then now, let's import all the CSV files into the R environment. Maybe that's something next step, do data analysis, we need R. Firstly, you can also check everything. We use the global, anything in CSV, let's check. Because as I mentioned, so we easily find, okay, I can count 1, 2, 3, 4, I unzipped 7 files. But if you unzipped 100 zip files, it's very difficult for you to double check in your local if you unzipped 100 or not. So you can write some links like this and to say, oh, I find the 7 CSVs based on 7 zips. That's very fair because I know each zip will become 1 CSV. So from here, you just see map CSV files, which I defined. That's all the 7 files I find from this local folder, and do the read.csv. So the read_CSV is also a basic function. Everyone, like if you want to use R, import dataset, that is a must-to-know function. Then we use this to create a data list. And this will take a little bit longer time because if you read the local environment, you will find at least you have around 400 megabytes for most of the CSV file. So you are going to see the red button a little bit longer, staying there. And until you see the red button is gone, that means you finished this step. But definitely, we need to be patient to wait a little bit. So this is to try to import everything into your R environment. And if you look at here, in the R environment, there is a pie chart. And they are going to increase the number. This is to show the computer or R Studio is using your memory and how much memory they are using to import those data sets. I think for this size of data set, everyone should be okay to import without any memory limit issue. Okay, so on my computer, my red button is gone. So I assume I have imported them. And if you want to know where it is, again here, it's pretty big. I imported 4 gigabytes. I call it data list. And again, you probably know if it is a list, it is not ready. You need to have a tbl_df or data.frame type. Then you can use them. Then you know the next step is we need to make sure to put them separately in the environment. And what I'm going to do now is I do a little bit cleansing. And if you read the underscore thing I mentioned in the next chunk is, you are going to see most of the separator in the original file, they use hyphen, they don't use underscore. But when they do part 7_7, they use underscore. So if you really want to rename your file a little bit nicer, you can do that. So this is an optional step, but you can do it also. You don't need to manually do you can just do it in our environment. So what you are going to do is, firstly, you extract every original file name, because we have that CSV files ready in local. Then we remove the extension .csv. That's easy to understand. The last step is to replace all the hyphen with underscore. So we have a little bit more consistent name. And here we go. The last step, list to environment. Remember what we did for Gapminder. So what I want to do is I list everything, and you are going to see basic company data, they are listed here. And the part 1 underscore 7 and tier 7 underscore 7. And the last thing may be a little bit difficult for you to think in an unzip way is you don't really need to open the unzip file, but you can still write some R function to read the file for a little bit information. For example, you have a data dictionary. You know there is one column, so I randomly open one column or one file of the basic company data. And you are going to find there is one column called reg address, that's registration address country. So there will be one column, registration country, somewhere here, the column I. So for every single file, you are going to have this column. And you can do a lot of things. Don't need to open the zip file or the CSV. So what I can do is, based on the zip file I have, I will do a map DFR. So this is a variation based on map function called I want to map everything and create a framework, create a tabular data. And I know every single item I want to go through is that zip file thing. So go through each zip file, read underscore CSV. I only want to do something for this country, registration country column, and summarize the same thing for Star Wars. I just want to know the unique countries and what they are. And if I run this, that means I didn't use anything from my R environment, because they are not called basic company data. Anything is I read from the local computer, those zip files. And you are going to see in the console, they are doing index very quickly once I write down these codes. But still, it's line by line. And I successfully created something in the environment called reg at profile. And if you open it, you are going to see, let me make it clearly. I read directly from the zip file, and I count in each zip file how many unique countries in that specific column and what they are. So sometimes you don't, because after import those basic company data, it eats your memory, takes your storage, and R is very sensitive for the memory. I'm not saying you don't need to import them ultimately, but if it's just some primary stage data check, this is something for your consideration. Okay, great. I think we still have like around 10 minutes to talk about scenario 3, and are you ready for a little bit advanced talk? If you are ready, let's open the scenario 3, and I will clean everything here because they are useless now. So for scenario 3, please open both because we have limited time. So I want to talk about them like side by side. Yes. So I give you 2 different scripts. Actually, they are downloading the same data set. If this is your first time, let me introduce you to Columbia Academic Commons. So this is Columbia's academic repository. If you are a PhD student, after graduation, you will definitely deposit your doctoral thesis here. And if you are any on-campus scholar, you go to conference, or you have manuscript, or you have your own data set or something, you can consider to deposit your items here. And this is an open access resource for everybody online. So that means Academic Commons provide global access to the scholarship at Columbia University. And today I'm going to show you bulk download, right? So we use the doctoral thesis as example. So for example, easily you can filter out degree equal to doctoral, then you get almost 100,000 records in this database. And now my task is how to download all those records to my local computer. I only want to know the title, the name, the year, and the abstract, etc. So there is a back-end thing. If you scroll down to the page, there is a tiny word called developer resources. So Academic Commons provide an API which we can use for this practice. So if you go to the API page, you're going to see the search button called Get. And inside this Get interface, there is one button called Try It Out. So you can search exactly the same thing you did in that user-friendly interface, but in a more developer style. And we don't need to worry about other parameters because I know my filter will be here, degree level equal to doctoral, right, doctoral. And if I only do this and do the execute, you're going to see the metadata tell me, yes, the total number of the results will be 9989, which we get the information on the user-friendly interface. And they will tell you every page you only get 25 records, and the page is equal to 1. So in that case, how many pages do we need to download? That is awful, right? And when I recheck the parameter, for the per page limit, they say, okay, fine. The maximum for each page, you can do 100. That's a little bit helpful, but not very helpful because it's just 100. I run the code, and you're going to say, yes, I probably get 100 records in a shot. But in that case, I probably need to download 100 times so that I download every single thing. And the other thing is how to download them. Should I run a for loop or while loop? That is very engineering mindset, which is nice because that is the correct way to think about. So this is the right timing for a lot of people, if you are a user, begin to think about maybe it's time to write a loop. But as I mentioned, I give you one option to use package. That is because there are so many people in non-CS and engineering background. They are doing more and more API data study. So if I teach this session 3 years ago, I'm not going to introduce you to use package. I will say, okay, for loop, while loop may be the best buy for your case. And that will drive a lot of researchers in non-CS background crazy, right? And today, when I re-prepare this session, and because I used to have an AC API workshop 3 years ago, and at that time, I show people how to write loop, and I see attendees' faces are very frustrated and feel like I don't want to be here, I want to leave, right? So I was like, maybe this time I will see the same faces. But fortunately, as I mentioned, always check if there is a package. And I find a new package called HTTR2. So before there was HTTR, not HTTR2. So I use HTTR. I still feel in some step, I feel a loop is way much better in my opinion. But after I try this, I feel like, okay, maybe I can introduce this to most of users firstly, rather than show them the while loop and everyone feels so sad. So let me load all the libraries I need. If you fail to load some library, that is because you didn't install them. Because, for example, HTTR2 and JSONLite, those are external packages you really need to install by yourself if you never install them. And the first thing is we need to set up a download link. And if we come back to the academic API, you will see this URL link, which will help you to download all the records. If you don't know why that is, let me copy paste the URL link and print it out in any web page. You are going to see all the text information will be here. They're just in a very messy way. But you are going to know this URL link will help us to extract all the information. But later we are going to reshape it in a nicer way in R for human to read. The first thing is based on the URL link we have before. Let's look at the structure a little bit closer. The only thing for 100 times download different will be just the page number. The other parameter will be exactly the same. So that's why the basic idea is a loop. If I know I need to change page equal to 1 until page equal to 10, then I need to do a for loop to say from 1:100, page equal to da 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 da. And for this package R, what they can do is, after you set up a basic URL link, so the page equal to 100, per page is 100, degree is equal to doctoral. Those are fixed term, right? So those things are easy. And this is your initial check. And after you do the initial check, you are going to see based on the outcome, you know total number is equal to 9983. So we are going to use the dollar to extract that total result number as our basic. So you see immediately in the console, in the environment, the total results is equal to 9989. So that means we successfully extracted this number. And maybe half year later, you can rerun this code, because at that time when you rerun this URL link, the metadata will change to a different number because people are graduating soon, and the number will be way much bigger than this. So this is reproducible. And now, how many pages we need? We know the fixed number is every page 100. So let's divide it by 100. So we need to download 100 times. So that's for now. But later we need 105 or 110 pages. And we come back to this very easy to understand iterative function. Based on this base, what are you going to do your iteration is, I know the parameter name is page. It starts from page 1, which I did. The offset means increment. I want to do it page by page, so increment is 1. And the maximum records, the requests, will be the total pages I need. So after that, you don't need to run any for loop or while loop. Just run this function, and you are going to see the iterating is going on in the console. And they also show you the process bar. Again, we are a little bit over time, but what I try to tell you is, yes, you still need to know the logic, like what I try to share with you with that for loop or while loop thing. So for while loop is, you don't know it's 100 pages. So you set up that condition, like what I did here is we want to do while it's empty. So here is the thing. When to stop, I will say, go to download, download, download until the page is none, then stop. But you see I have a very long loop to achieve that. And this iteration function just help you do that thing at the back end. So you still need to know the logic, then use that iteration function. Or you will never understand API, and you will never understand the data flow. So I will stop here, and feel free to stay a bit longer or ask me any questions is related to R or just related to data. My colleagues are still here, so we are open to your feedback. Please fill the survey and give us suggestions and feedback. Thank you.